Hey, this is Horner, and this is the circuits review free response question number 4. So we have a couple different light bulbs, and you'll notice that the filament in light bulb A is very thick, and the filament in light bulb is very thin. So both have the same length, though, but this one just have a bigger cross-sectional area. They're connected to a battery. And it is an ideal source of EMF. So remember, that's the same thing kind of as potential, but we use the word EMF for batteries, and we use V for measuring the voltage in each one of the bulbs. Do more electrons enter bulb A's filament every second or B's? Well, remember, they both have the same current. So the current here, which is I, is going to be equal to the current in this one. It flows slower through this one and faster through this one, but if I have 10 things go through this one in a second, so 10 charges per second, I'm also going to have 10 charges per second here. The difference between the two is they're going to flow very quickly through this one, and they're going to take their time through this one because you can get more of them. If I get 2 people at a time through this one, and I can only get 1 person through a time at this one, I've got to send 10 people through. They've got to walk faster than if they're walking side by side. So that's the difference. 10 coulombs per second. So if I did 10 coulombs per second, remember that is current. Current is the flow of charge per second, and Q over time. So both of these I's are the same in series, both have the same current, and that is due to Kirchhoff's current law or junction rule. Either way, whatever goes in and comes out, whatever goes in has to be the same as what comes out. So if you have 10 coulombs per second here, you're going to have 10 coulombs per second here, and vice versa. Which bulb is brighter? The brighter bulb is going to be bulb B, and it's brighter since power is equal to current squared times resistance. The resistance of B, you'll notice, is very high because we don't have as big of a pipe, and we can say that by just saying the resistance of B is greater due to a smaller cross-sectional area. We know that because R is equal to rho L over A. So the smaller this is, the bigger this is. And both have the same current value. For the last part of this one, there isn't anything. So this one's just super short. And that is the end of F4.